Let's create this metric and create. Yes, we want to create and go to this grids, beam grid. Let us make one frame 5 meter, and this is 1 meter distance, so one small frame. Let us give this load here and fix support here. How it behaves we will see. So let's go to this properties and section database. In section database we will create simple beam section. We can give the property. Let's give an example of this W4/3. Let's add it and let's assign this to the view. So it's assigned to this view completely. We are given the properties. Let's go to the supports. We are going to create the fixed support. So let's add the fixed support, this fixed support at this base. Assign. So we have assigned this fixed support, and let's go to the loading. Add a new load case. We will add it. Let's see, load case 1, add it. And then in this load case we will add the load of a concentrated vertical load, a nodal load in this direction minus 10 kilonewton. We'll add it. So this load we are going to apply this joint, not in the Z direction, it should be in the Y direction, so we will edit by minus 10 in Y direction, not in the Z direction, so we'll modify it. So we have modified it, we have seen this one. So let's go to the analysis and we will perform analysis. Then let's go to this run analysis. Once we run the analysis we will see it how it behaves. So 0 errors and warnings done. We can see these results. Go to post processing, right? So apply and see here how the displacement views. Go to the view and select this view, and here you can see how the displacement, it's a single curvature and this also single curvature. So let's see the beam results. So you can see how the reaction comes. Since this is the loading is applied here, it will try to bend this, right? So it will come this way, this joint, and then this is bending like this, and from here to here it is, here it says slope is 0, no? So it will come like this. So it becomes like single curvature both. That's why this bending moment is going from this point. It says force into distance, this distance, whatever this distance is there. That distance is, I think, 1 meter we applied, 10 kilonewton we applied. So moment, if you see it, it's a 10 kilonewton meter, right? This is 10 and this is distance is 1 meter. So here moment is 10 kilonewton meter. That will be like this, it will affect, right? So then for this member, this is the only moment it is there, and this axial force it will come. So this moment is throughout it is the same, because this is the force and this is the distance. For this member this force is parallel, so whatever the moment at this point, it will be the constant moment it's coming. This is okay. Let us see this member's moment. If you see it, second member, it will be same moment it will come. See here's 0, 1, 2.5, this one, because it's increasing from this point, it's increasing. For the second member it is continuously, it's a 10 kilonewton meter only, the force. And you see the axial force for this member, this member's axial force is 10 kilonewton. For this member's shear force is 10 kilonewton, we applied it, so same 10 kilonewton will come. For this member axial force is nothing, 0, yeah, and shear force is 0, right? For this vertical member axial force is 10, shear force is 0. For this horizontal member axial force is 0 and shear force is 10. This is correct. So this is how it comes. So this member right here, whatever the force is coming, for this shear force for this beam is this one. For this member this is a force, so axial force is 10, but there is no shear force. For this member there is no axial force. That's why here it's reflected here. Okay, then now let's go back to this and we will see this deflection shape. You see the displacement shape, how it becomes displacement shape. So because of this load, this joint displaces, and this joint also displaces downwards. So from this one, if you see, this joint is displacing, so this is bending like this and this is also bending like this. So it's a single curvature, and this also single curvature. This radius of curvature, this radius of curvature. That's why bending moment is on only one direction. Like this it will come. Bending moment diagrams. So here, how much is the vertical displacement? If you see this one in inches, it shows this is 5.23 inches. It's coming x direction. The displacement in x direction is laterally, this is displacement, and this is this much displacing this joint. Node 2, node 2 or node 3. Node 1, this is 0 completely, right? So that is fixed completely 0. Node 2 is moving, and node 3 also moving. This and this both it's moved, no? 5.23, 5.23, and vertically this node 2 is 0.004, but node 3 is minus 2.244. Okay, that means this is the node 3, this is the node 2, this is the node 1. Node 1 is fixed, all 0. Node 2 is x direction itself, it is moved 5.2 meters. 3 also it's moved 5.23 inches. Okay, both it's moved like this. It's like this. And from this joint, from this point to this point vertically also it's 0.004. It's very minor displacement. And this joint minus 2.24, from here to here it's minus 2.44. So it become more like this. That's why the displacement is like this. Okay, so third joint, it moved horizontally as well as vertically more because of cantilever kind of thing. This member is actually restrained, right? So that joint is moved very less, 0.0004, 0.004 displacement. That's y direction. Y direction is the vertical direction. Here you see is a direction out of plane, that is no force. That's okay. Then R is at rotation also. You can see this joint is rotated. This joint, because of this force, this is rotated like this, no? So this is the rotation. This joint also rotated. 0.053 joint 0.058. So this is okay. We will end this example.